leading coefficient is 1, which kind of is helpful because it means that when you factor this, you know it's going to be x and x. So then you need two numbers that multiply together to get negative 35, but add together to get what? 2. So what are those two numbers? Negative 5 and 7. Test it out. Always test. Always test. You get x squared plus 7x minus 5x minus what? 35. And does that come out to be what you want it to be? Yes. It does. It sure does. Excellent. It does. Nice. Okay. Who has another one? Oh, okay. So that would make it probably impossible. But let's do this one because it's a good one. Yeah. So first of all, what's the first thing you always look for when you're factoring? What's the first thing you always look for? Do you have some sort of GCF that you can pull out? Is there a GCF? In this case, no. I mean, you think there might be 3, but 3 doesn't go into 25. You might be n, but there's not an n in the first one. It might be n, but there's not an m in the last one. So there's no GCF. In this case, what is the GCF? 1. The GCF is 1. Everything always has a common factor of 1, but in this case, the greatest common factor is just 1. Can you make sure the door is shut, Gabby? So one thing that's annoying, yeah, there's two variables, but you might guess that it's 3m and 3m or something to start with. And then the other two have to multiply together to get what? 25n squared. The other two have to multiply together to get 25n squared. But what do you know about the positivity or negativity?
Two negatives.
Has to be two negatives because the middle term is negative and the last one is positive. So do you want to just take a guess? How about negative 5 and negative 5n? What do you do now?
Wait, so
yeah, go ahead, Noah.
when the second term is negative and the last term is positive, it's always
Both.
two.
It has to be because look, these two things have to multiply together to get this.
So it's
But
just
then
like,
you have to create a negative. So you know negatives have to be in there. But in order for the last term to be positive, you're multiplying two negatives together. So when you multiply this, what do you get? 9m squared minus 15mn minus 15mn plus what? 25n squared. And does that actually come out to be what you want it to be?
yeah.
It does.
Does your pen work better on that?
It's different. I have to get used to this. It's very different. The other one is kind of like harder and it feels like smoother. It's kind of like writing on glass in a way. And I got used to this. This is much more, there's a little give to it. So you'll notice that like when I did a circle here, do you see how that's like not quite smooth around the 19? Yeah. Like I actually have to press with a little bit more force, but because it is pressure sensitive. You see how it's getting thicker? Which is kind of nice. Okay. Yeah. And the erases apparently.
Yeah, you have to click a button and then use the
Nice. Okay. I'll have to change that. Okay.
Wait, can I see the pen?
Silver. Okay, another one. What do you got? Another one. Hold on. Where did the recording thing go? Oh, it's just not showing up. You could actually write this. This is the same thing twice. What's another way to write that? 3m minus 5n squared. You just need to make sure you check it, Gabby. You can use those formulas as long as you check it. Okay, another one that you did. Another one. Anybody have a good one?
22.
What?
22.
22? Okay. 22. Oh, yes, this is an excellent one. K cubed minus 875. I know some of you worked on this. We had this up on the board. I think Chris and Gabby were working on it. What's the biggest clue to how you're going to have to factor this? There's a single number up there that's your huge clue. What is it?
7.
No.
5.
No. The cube is your biggest cube. Yeah. Not what you're going to do. What is up there right now that is your biggest cube? So that gives you a hint like, oh, you want to use difference of cubes. But you'll notice that is 56 a nice cube? No. Is 875 a nice cube? No. Then you go back to thinking, what's the first thing I told you to always look for? GCF. Is there a GCF? Yes. What is it? 7. If you factor out a 7 from this, you end up with what?
8.
K cubed minus, and like, okay, 7 into 875, if you have to, it's going to be 1, 7, 1, 7, 2, 14, 3, 5, 5, 125. Oh, now what do you see? What is this right here? What is this? Exactly. That right there is the difference of cubes. So now what can you write it as? If you have that as the difference of cubes, that's 7 times something cubed minus something cubed. What goes in the second one? Can someone tell me what goes in the second blank? Chris? A 5. What goes in the first one?
2x. Oh, sorry.
Nope. 2k. 2k goes in the first one. Now, the pattern that you have to remember, the formula you have to remember, everybody, a cubed minus b cubed is equal to what? Do you remember what it is? What's the formula? They do it as x cubed minus y cubed.
A minus b.
So it's a minus b times what?
A squared
plus
a times b.
Is it 2 or 1? It's 2ab? Is it this one?
Yeah,
No.
Is it that?
No, the second one's a negative.
Isn't it just AB in the middle?
Is it
One of
just
them's a
ab?
negative.
Well, is it just negative on the, is it just negative in the front, or what is it? So it,
I don't
is it this one right here? I gotta make sure I get this in here. Hold on a second. Let me pause. So this one, of all the formulas that are kind of annoying to memorize, I know it seems annoying, but you really gotta memorize that. You gotta memorize the one in the yellow box. You really gotta. It's important that you do. Okay, well, go ahead.
What are the, like, I know, like, the difference of cubes.
Without question, have to memorize difference of squares, difference of cubes. Those are the ones absolutely without question. It would be helpful if you memorize that one, and it would be helpful if you memorize that one. Those two, though, you must. These two must memorize. Must. Okay. So in this case, it's similar to one we did already. It has two variables in it. The leading coefficient isn't 1, so you might be a little sad, right? But if you break it up into, what, 2k, 2k, and then what's the last one's 49. That's kind of nice. So what do we want to break it up into? It's all positives, so do we have any negatives involved? So plus 7 what? 7r and plus what? And then what do you have to do at this point?
Oh, that one was easy.
But
I'm
try it.
sorry. I didn't.
Wait, why are you apologizing? You don't have to apologize. Like, that's the thing about factoring. Once you get better at this, suddenly things that were once really challenging will start snapping into focus pretty quickly. Does that one work? Yeah, 14 plus 14 is 28. It does work. That's fine. So how about I pick one for you guys to do?
Is that where you went right there?
Yeah, you're done. You have to test it. You have to test it. Now, is it the same thing twice?
Yeah.
So you could write it as 2k plus 7r squared. But you make sure
Wouldn't that be the
that you test it.
sum of
Are we gonna need to write it that way? Though?
No, this one is a perfect, that's in perfect square trinomial right there. See? Perfect square trinomial. It's this one. We just use that right there.
and we don't have to
Two
write it as
variables
the
always.
second.
It's harder. It makes it harder. But once you practice it, you'll be like, oh, okay, that's fine.
Yeah, I should have.
You'll get there. You'll get there. What's the first thing you're supposed to do?
Kids.
Kids.
Finally.
Is the
GCF.
screen bigger on that too?
Yes, it is. So GCF. So now here's the thing. Do you have to know like what the GCF is from the get-go? No. You can pull things out one at a time. So I'm like, oh, I'm just going to pull out a 3. If I pull out just a 3, what's left in this one? Look up here.
6p.
6p to the 5th minus 8p cubed plus 4p to the 6th. Now what could I pull out?
Let's do
2p3.
You could put 2. So if I pull a 2 out, what do I do with that 2 in relation to the 3? Yeah, so 6 times, I pulled out a 2, so it's going to be 3p to the 5th minus 4p cubed plus 2p to the 6th. I pulled out a 2. So in this one, I pulled out a, what did I pull out there? Pulled out a 3, and this one I pulled out a 2. Oh, what can I pull out now?
p.
P to the 3rd. So 6p to the 3rd times 3p squared minus 4p plus 2p to the 3rd. Now, Fitch, what did you do to this? There was one more thing you could do to this to make it a little bit more in proper form.
Mr. Seaman, what did you
Couldn't you take out 3p? Oh, did you?
We already took out everything we
but
can.
then shouldn't 4 not have a p?
Yeah.
Oh, thank you. It's not, what did I not have a p. Thank you very much. So that should just be minus what?
Minus 4.
Minus 4. So now what did you
Four
do?
First.
We had to put it in the right order.
Right order. And what's the right order? You like putting it in what, from what to what?
Greatest.
Greatest what?
Power.
Greatest power. So it's going to be 2p cubed plus 3p squared minus 4. It would be great if everybody did that last little thing. When I'm looking at a lot of these, it's really great when they're written. Why do we like that? It's power 3, then power 2, and then what's the power of p right here? Nope.
0.
0. It's not there. It's 0. The power is 0. Nice. So what about this one? I saw there's some really good work you guys did. One of the methods you use kind of runs you into a dead end where you can't go anywhere. We can go a little bit. So one way people might have done this is I saw some people group things kind of like this. What can you factor out of m cubed and m squared? You could factor out m squared. So you get m squared times m plus what? 1. Minus, and what can you factor out of these other two? N squared times n plus 1. So this is true. I'm totally happy with that, but can you go any further?
No.
No, you can't go any further. It looks like you should be able to do more. It looks like grouping, right? The problem is, what's the problem? This is m plus 1, and what's the other one? You can't go anywhere else. You have m squared apples and n squared oranges. You can't add those together. What you can do, this is a great problem because you can rearrange it a little bit and do a different thing. So instead of looking at it like this, I could look at it as m cubed minus n cubed plus m squared minus what? N squared. What do you see? And what else do you see? Squares. This right here is difference of cubes. This right here is difference of. So let's do the difference of squares. What does m squared minus n squared factor into, Meg? What does that factor do? M squared minus n squared. This one right here. What does that factor into?
M.
Sorry, Meg. Yep.
M.
M what?
Minus N.
Times.
M plus N.
Correct. You have factored difference of squares. Doesn't matter what order you put the 2 in. That's correct. You can do either one. Okay, so that's nice. But do we have difference of cubes? We do, and you need to remember what it's going to be. It's going to be what? M minus times.
M squared plus mn plus n squared.
Correct. And these two are added together. Now here's the thing. What's in both of these things? What's in both of them? M and n. And this is where I have to be real careful. This is in both. So what can we factor out? M minus n. So you have to be real careful at this point. Some people got real close to the proper answer. It's m minus n times what? M squared plus mn plus n squared plus what? M plus n. You have to factor out of both of them. You're pulling it out of both of them. Now, could you clean up the middle part a little bit if you wanted to? You could.
How?
Well, not. How do you clean it up? It's m minus n. You could write it as m squared plus mn plus n squared plus m plus n. The difference between this and this doesn't. Either one is okay. Because here's the thing: is this right here? Are there any like terms in that green line right there? No. There's no like terms there. So there's nothing we can combine, and there's nothing more we can factor.
Where does the m minus n go?
What do you mean, where does the m minus n go? It's right there on the end. Like, the answer to this question, the final answer to this question is this right here. You need all of that right there. That is the complete factorization. It's really cool. If you multiply this out, what do you end up with if you multiply this out? The thing up at the top. Okay, so we need to pivot to something that is super important, and it's going to start with this question right here. If I have two things multiplied together and they equal 0, what do you know has to be true?
Zero.
At least,
Oh, okay.
at least A or B, one of, must be what? Must be 0. The only way to multiply two things together and get 0 is at least one of them has to be 0. Do you agree? So you have this thing called the zero product property. It says if two numbers have a product of 0, then at least one of those numbers must be 0. So here's the thing. It might not seem like that's super helpful, but it's incredibly helpful. Instead of A and B, we have x plus 6 and 2x minus 3. Those two things multiplied together equals 0. So if A times B equals 0 means that A is 0 or B is 0. So let's write this out again. No, careful. We know A times B is 0. What does that imply? A equals 0 or what? B equals 0. So if we go over here and use this, what does this statement imply? Either what, Maggie? Yeah.
What'd you call me?
Sorry, Gabby. Yep, either.
Either x is -6.
Nope. So I'm not asking for the answer. I'm asking for the next. Do not solve these. Give me just the next piece. Either what is true. X.
Either x equals 0.
No, no, no. There's two things here. The green thing and the purple thing. What's the green thing?
0.
No. What is the green thing? Literally, what did I underline?
X
Either
is
x plus 6 is what?
0.
Or
2x minus 3.
2x minus 3 is 0. And you are absolutely correct, Gabby, that what does that mean? X is or 2x minus 3, sorry, 2x equals 3. So what does that mean? X is what? 3 over 2. If you have two things multiplied together to get 0, one or the other is 0. Do not skip the algebra. Do not skip the algebra. I can guarantee you're going to be flying through a ton of these. You're going to do the factoring. You're going to get right to the end. You're going to do 95% of it correct. And then you're going to be like, x is 6. Well, x isn't 6. It's what? On this one, it's -6. So are we always going to be given an equation in nicely factored form? No. So sometimes what are you going to have to do first?
Factor it out.
Factor it out. You're sometimes going to have to factor it out. So the key thing is this. Remember how this is the name for standard form, ax squared plus bx plus c? What's on the other side here? 0. So to use the zero product property, what do you have to have over on the right? A 0. You have to have a 0. It has to equal 0. Can you do the same work if it equals 2? No, you can't. It has to equal 0. So the first step, another way to say step 1 is clean up what you have. Sometimes you might have to combine like terms. Then what do? Oh, my favorite thing. I love this. What is the factoring? It's so much fun. I love factoring. You're then going to use the zero factor property, find solutions, and check. So kind of like with any sort of factoring, not kind of like what's the best way to get better at these? Practice. So first of all, does that equal 0?
Yeah.
Yes, it does. Does it literally say equal 0? Yes. So do we have to move anything around? Are there any like terms? No. So at this point, we get to step 3, which is factoring. So like, let's look at this. What's that first thing you always check when you're factoring? GCF. What can you pull out of that one, Chris? You can pull out a 3, and it becomes 3 times what? X squared minus, ooh, what is it? Yeah, you'll get it. 36. Correct. Oh, now what do you see, Chris? What's x squared minus 36? What do you see? Difference of perfect squares, exactly. So what does that factor into, Chris? Finish it.
X minus 6 and x plus 6.
X plus 6. So do you have a bunch of things multiplied together?
Yeah.
You have 3, x minus 6, and x plus 6. Does that 3, do we care about that 3 anymore? No, because can 3 turn it into 0? No, because 3 by itself isn't 0. So what are the two things? What's the or statement, Hannah?
X minus 6 equals 0
Or
x
x plus 6 equals 0. So x is equal to 6 or what? X is equal to -6. Exactly.
Could you write that as like x equals plus or minus 6?
You could. You could say at this point x is equal to plus or minus 6. Absolutely. So we just did the first one. What's the difference? What's the primary difference about the second one? What's the primary difference? Does it equal 0? No. So what's the first thing you need to do? Make it equal 0. So what's the easiest way to make something equal 0? What? Subtract. You said subtract one side, right? So let's take this side and subtract it from both sides. So what do we have? 2x plus 1 times x plus 1 minus what?
2 times 1 minus x plus 6.
Well, minus 6, because you have to make it a minus. Hey, does it equal 0? Yay, so step 1 is complete. Is this in standard form?
No.
Why not? Why isn't it in standard form?
There's no square.
Yeah, what is standard form? It was a what?
AB squared.
Close. It was ax squared plus bx plus c is equal to 0. You want it in, what is this called? Standard form. You want it in standard form.
Why did they call this standard form when there's also that other standard form?
There's general form is the other one. Yeah, there's the naming conventions aren't the best, but let's put it in standard form. I'm pretty sure they call it standard form, right?
Yeah.
Right? Didn't they call it standard form? Right? Wait a minute. Standard form. Yep. Good. Okay. So let's do this one. Where is it? I lost it. There it is. So what do you have to do to turn this into standard form?
Simplify.
So give me one word. What? Distribute. So in this case, you have to multiply it out. So we have two things multiplied together right here. Can someone tell me what that multiplies out to? Gabby. All the pieces.
2x
Squared plus,
plus 3x
well, 2x plus x plus what?
plus
Plus 1. Now what about this next piece? Minus what?
minus
2
0
plus 2x minus. Everybody, look at that line and make 100% sure that makes sense to you. What's 2x times x? 2x squared. 2x times 1?
2x.
X times 1? 1 times 1. And then you have minus, it's negative 2, right? Times 1 is negative 2. Negative 2 times negative x is positive 2x, and then nothing happens here. Is this in standard form yet? Why not?
You still have that extra.
Because you have to combine like terms. You have to combine like terms. So how many squares do we, how many terms have a square in it? I just see that one, right? So we'll take care of that, and it becomes just 2x squared. Nice. Then we have 2x and x. How many x's? 3x plus 2 more is 5x. And then we have 1 and minus 6. What's that? Oh, 1 minus 2 minus 6. What's that going to be? Minus 7. And what does it equal? 0. So now, are we in standard form? So first step was making it sure it equals 0. Then it's put it into standard form. We have to multiply, clean it up a little bit. What's the third step? What do we have to do now? Factor. Love factoring. So now we're back to what we love to do, which is factoring. Now, what's the one thing that makes this one a little bit harder?
The coefficient isn't 1.
The leading coefficient isn't 1 and leading coefficient is 2. You both said perfectly what the answer is. Very good. So it's kind of annoying, but at least 2 is a small number, right?
Yeah.
So at least we only have a few options. So what is it? 2 and just x. 1x, exactly. And it equals 0. Okay, now we have to play around with it a little bit. At least 7 is prime. It's positive. What are the signs going to be of the next two terms? One has to be negative, one has to be positive. Should I put the 7 right here?
No.
Why not?
We're gonna multiply by 2.
And why don't you like that? It's going to be big, and we have a 5 there, right? So now you just have to play around with the signs. So we know the 7 is going to go there, and the 1 is going to go there. What sign should go first, positive or negative, do you think?
Positive.
Positive.
Let's make it positive and make this one negative. Someone said it over, there's only 2 answers. Half of you say 1, I'll just pick the one that I want. If we had flipped it, we still have to test. We still have to test. We still have to test this, right? Remember, is testing important? So if we test this, you end up with 2x squared minus 2x plus 7x minus 7. 2x squared plus what? Is that what we want?
Yeah.
That is what we want. So that was our check right there. Ah, how many things do we have multiplied together? One thing and another thing. Yay. So what is the or statement? Can someone raise their hand and tell me what the or statement's going to be? David.
Oh, wait,
What's the purple one?
2x plus 7
Mhm.
0, or x minus 1 is 0.
Or x minus 1 is equal to 0. So now you do the algebra. 2x is equal to, x is equal to, or x is equal to 1. So you, at the end of these, I really like it when you do this. Circle your answers. Question.
What happens if you can't factor it after?
You made everything equal 0, right? So you get negative x cubed plus x squared minus plus 6x is equal to 0, like that. What did you factor out at this point? I like factoring out negative x to make it positive. Kids, girls, can you turn around for a sec? So you have negative x times x squared minus 6x. Sorry, minus, I can't, it's this, and that's gone, sorry, equals 0. Now, can you factor that trinomial? Yep, it's x minus 3 times x plus 2. So, Meg asked, what about that negative x out front? Well, it's 3 things. How many things can you have multiplied together, theoretically? You can have all of them, right? If the product is 0, Noah, at least one of them is 0. So how do you make this first term 0? Negative x is equal to 0, or x minus 3 is equal to
0.
or
X plus 2 equals 0.
so how many answers does this have? 3. So we have x is equal to 0, or x is equal to 3, or x is equal to? Exactly. Very good.